this section. And of course, solving differential equations involves solving some integrals. So let's look at the first example. In this case, we've been told that the rate of increase in a population denoted by P, is P, and the rate of increase is proportional to the population itself. That means we have a multiplicative factor of 3 times by P, which is actually the rate of change of the population. Of course, this is a population of microorganisms in terms of hours. T is measurement in terms of hours, and T is always a constant, is a positive constant. We've been told that the initial population has size 8. So, what the word initial means is that at time t0, P equals to 8. They have two questions asking us to find the model for P in the form of P equals to capital A with exponential function 3t as the exponent. So we are to find and calculate the value of capital A. Where do we start here? We start with this formula, and we are going to separate the variables as we would in previous examples. That means multiplying by dt. What we will have on the right is dt, and on the left we will have 1, or I'm going to leave the constant here, 3 on the right, and take 1 over p to the left. Well, p in the left will appear as 1 over p. Then we can put the integral signs in front of these constants. Because we have a dp here, it only makes sense to integrate with respect to p, and we have dt here. Integral of 1 over p is logarithm of p. Integral of 3 with respect to is 3t. We are going to have a constant here, c. What we will do is take the exponential function then. P will be e raised to the power of 3t, and as I explained before, this addition constant on the right side in exponent means that we have a multiplicative factor of front of e. What is that? Is simply e to the power of c, this constant here. But we don't need to write it as e to the power of c, we simply write it as a constant a, because now we can substitute the values we were given for the initial values to calculate what value of a is. Capital A can be found like so, substituting 8 here and raising e to the power of 0. 3 times 0 is still 0, will give us a 1, and simply that will tell us a is therefore 8. Let me write e to the power of 3 times 0, and that this simplifies to 1. Having found the value of a, we rewrite the model as p equals to 8 times e to the power of 3t. In the next part of the question, we are asked to find the nearest 100 the size of the population at time t equal to 2. Well, that's not difficult at all. We substitute value of 2 into the equation that we have found so far, and we will get number as such, and we will round it to the nearest 100. Nearest 100 is 3,200. The next part of the question is asking us to find the time at which the population will be 1,000 times its starting value. Now, they are not straightforward with us here. What the starting value was 8. Therefore, we have to take 8 and times it by 1,000. We are going to set the population to 8,000 and solve this equation to find the value for t. Therefore, We'll start by dividing by 8. We'll have 1000 equals the exponential of t 3t. We are going to take the logarithms of both sides. So we'll have log of 1000, we'll divide by 3, and at this stage we can distribute the 1/3 for logarithm of 1000, and that means taking with logarithm rules, bringing the power here, and we know 1000 to the power of 1/3 means cube root of 1000, and cube root of 1000 is simply 10. So t will be log of 10 when the population is 8000. Log of 10 is a number such as 2. Log of 10 is actually 2.3. Now, this time was in terms of hours, so we're going to take that 0.3 as a decimal point and multiply it by 60 minutes so that we'll have an accurate answer, more accurate answer, such as 2 hours and 18 minutes. This is the final answer, 2 hours and 18 minutes. In the next part of the question, we are asked to tell the examiner one limitation of this model for large values of t. Okay, so the hint is given to us in the question that for large values of t, what will happen? Well, looking at this equation here that we found and graphing that, any exponential function, particularly with a positive value for t and a positive constant at the front, will be steeper, yet a steeper exponential function. And exponential functions mean an indefinite growth. Now, any population is limited by resources and food, so therefore population is highly unlikely to grow indefinitely. So, due to lack of food and space and other resources, the population will have to crash at some point. So, let's look at the next example here. We are given a cylinder. The cylinder is partially filled with water. The diameter of cylinder is 20 meters. What that means is that the radius is 10 meters. Flows out of the bottom of the tank through a tap at a rate proportional to the cube root of the volume. Right, we are asked to show that t minutes after the tap is opened, the differentiation of height with respect to time, derivative of height with respect to time, that is height of the water, is a negative constant multiplied by cube root of h for some constant value of k. So we are asked to calculate dH by dt. But where can we go and how can we do that? All we know is volume of the water in the cylinder, not the cylinder itself. We are mainly concerned with the water, is the base area of the cylinder multiplied by the height of water. We can find the derivative of volume with respect to height. That is simply pi r squared. Our value of r is a constant 10, so that is 100 pi. Now we have to calculate dH by dt. How can we get dH by dt? dH by dt, where we have dV by dH. This is not the right way around, is it? We can get dH by dV by taking the reciprocal of this value that we found. dH by dV is simply 1 over reciprocal 1 over 100 pi is now dH by dV. So we have h dH where it needs to be, but somehow we have to cancel away dV and get the dt in here. How can we do that? Well, the way to calculate to find and cancel away is by having found the rate dV by dt. So that means that our dH by dt is simply dH by dV multiplied by dV by dt. If we read the question carefully here, it does say the rate the water flows out of the bottom of the tank through a tap at a rate proportional to cube root of volume. That means that dV by dt is a negative constant multiplied by cube root of V. What is V? V has a definition of pi times 100 times h. So we can replace this in this equation here, and these dV's will cancel away and we're left with what we want. So far we know what the constant dH by dV is, so we are going to write here 1 over 100 pi and multiply that by this constant minus k multiplied by cube root. Rather, I should put the k further down so you don't confuse it with the cube root sign, pi times 100 times h. Now you can rewrite that as negative k, and the constant here, root of pi 100 over 100 pi, and we'll have the cube root of h here. What that means is that because I use the letter h here, let's change that letter h to some other variable name so you're not confused with the k that's given to us in this part of the question. If I change that now to here, we had a 1 and we had a dV here. So this, let's call this a negative j, doesn't matter. So this negative j multiplied by this factors here is giving us the negative k. So we can drop the constant, the negative signs, and say k is simply j multiplied by cube root of 100 pi over 100 pi. Okay, so let's look at the next part of the question. Okay, in part B of this question, we are asked to show that the general solution to the differential equation may be written as h equal to p minus q t all raised to the power of 3 over 2, where p and q are constants. Now, we came to the conclusion at the end of part A that dH by dt was some constant multiplied by cube root of h. Now we are to solve this differential equation with respect to t dt. We go ahead and we separate the variables. We multiply both sides by dt, and we have to divide by cube root of h. We leave the negative constant k on the right, and we end up with this expression here. Now that h's are all on the left and t's are on the right, we put the integral sign in front of every term, and we are going to integrate. We can rewrite the power of h on the left as h to the power of negative one-third. So then adding 1 to negative one-third will give us power of two-thirds, and we are going to divide by two-thirds. That means having 3 over 2 in front of h to the power of two-thirds. The constant negative k will simply have t multiplied by it, and we add a constant to c. Writing that to make it look neater, we can multiply the right hand side by two-thirds, because what we will need to get, if we look at the answer that the questions told us to write it in this format, we have to have h alone on one side on the left hand side. So what's next is to get rid of the power of h. That means we have to multiply the power by the two-thirds needs to be multiplied by 3 over 2, so it cancels away. So on the right side, the negative two-thirds kt plus two-thirds of c must be raised to the power of 3 over 2 as well, because of this constant here. Therefore, we will have exactly the power that the question told us we should get. Now, what is the value of p here? Value of p is negative constant two-thirds of kt. No, my bad. The t here is telling us that the value of q is negative two-thirds of k, and rather we can leave a negative sign behind because we have a negative sign in front of q. So q is simply two-thirds of k, and c is what matches up with your constant p. Okay, so I hope you found that helpful. Let's look at the next part and see if there is another part to this problem. In the last part of this question, we were told that the height of water was initially 27 meters, and 10 minutes later the height is 8 meters. We are asked to calculate the values of constants p and q. What we found the formula to be was in this format. So we can basically ignore everything else that we had been told, we had found, and now that we have this format, we can substitute the values of t equal to 0 and h equal to 27 into this equation to figure out p and q. And the other values that we can substitute is t equals to 10 and h equals to 8. So let's see what happens. When t is 0 and h is 27, we will have this format where q is going to disappear because we're multiplying q by 0, and we'll have p to the power of 3 over 2 equals to 27. That means we can get rid of the power by raising both sides to the power of two-thirds. 27 to the power of two-thirds is cube root of 27, which is 3, and 3 squared is 9. So p is 9. Using the fact that t is 10 and h is 8, we also know that the value of p is 9. So we do use that in our calculation, otherwise q would be impossible to solve. Now we are going to simplify this expression, raise both sides to the power of two-thirds. 8 to the power of two-thirds is cube root of 8 squared. Cube root of 8 is 2, squared of 2 is 4. Therefore, 4 equals to 9 minus 10 cubed, because 8 raised to the power of 2/3 is 4. Therefore, we can say 9 minus 4 equals to 10 cubed. Q is therefore 5 over 10, which is simply a section. We found that value of P was 9 and Q was a half. Now, in the final part of the problem, we are asked to find the time in minutes when the water depth is exactly 1 meters. So, we are substituting the values of P and Q into the equation that we have been told. Therefore, now we are going to substitute the value of H to be 1 and solve this equation for T. This equation will mean that both sides of the equation have to be raised to the power 2/3, but 1 to any power is still 1. So 9 minus half a t equals to 1, and switching 1 and negative half t with each other, 8 equals to half a t. Dividing 8 by half means multiplying by 2, therefore t will be 16. 16 minutes is the final answer. Well done for getting this far into the course. I wish you all the best, and I will see you in the next video.